Hey guys, this is your ECS20 classmate Ayush. I'm going to be making tutorials for this class, for especially for the topics that a lot of people are finding tricky. So I was recently approved by the professor for doing this, and I actually will have my page on Canvas. I think it's called like Ayush's video guide or something, where I'll be uploading all my videos. So if you guys ever if you guys ever find any of the topics in the class tricky, definitely check out the page. That should help you guys out. And also feel free to message me on Discord, and I'll eh, uh, I may make a video based on whatever you guys request. There's a good chance that I will. So yeah, let's do this. So this is my first video. I'm gonna be starting with the homework number 3, some of the topics in homework number 3 about direct proof and contrapositive proof, because I know that some people were finding this a little bit tricky. So yeah, I have 4 examples right here. This is not the example on the homework, but it's kind of similar. And let's get started. So here what we would do for the first one is you would want to prove that these are odd. So if these are odd, then this is odd. So we would first we would try the direct approach, and then we would in this we would substitute n and m with odd values. So n would be 2j plus 1, m would be 2k plus 1. Because that's how you write that something is odd. And then you want to prove that this is odd. So uh, we would write n squared minus m squared minus 1 as you would substitute the value. So it would become 2j plus 1 squared minus 2k plus 1 squared minus 1 is odd. And then so now we would want to simplify this again. So equals, or not simplified, just write out, yeah, simplify it, like write out the terms. So let's do the multiplication. 4j squared plus 4j plus 1 minus 4k squared plus 4k plus 1 minus 1. And there we go. Now from here, we again want to prove that this is odd, just to remind you guys. So let's simplify this a little bit. So it would become 4j squared plus 4j plus 1 minus 4k squared plus 4k, oops, minus 1 minus 1. There we go. Now we would cancel out the 2 1s like that, and we would be left with this. So notice that for the coefficient of 4 here and here, that can be you can basically steal out a 2 from that. Like they're both divisible by 2, and so that's why we're gonna steal a 2 out of them. And let me show you what I mean by that. This is equal to 2j squared plus 2j minus that's how you factor out a 2, and then you would have the minus 1 from there. Now next thing is so if we can simplify it again, so because both of these are 2, so 2j squared plus 2j minus 2k squared minus k minus 1. Notice that there's a big number inside these brackets, so let's substitute that for p, and then let me just draw a line right there. So for substituting this whole thing for p, it would become 2p minus 1, and by law, this always has to be an odd number. So we just prove that if n and m are odd, then this is odd, because this is always an odd number. And so yeah, let's move on to the next example. So it says if 2 minus 6n minus n to the 4 is odd, then n is odd. And what we would do is, let's first try the direct approach. We would have 2 minus 6n. And we would have to prove from here that n is odd. And honestly, that kind of looks a bit difficult because, um, like, because then we'd have to kind of try to factor out like n and make it be n equals 2 times something plus 1. And like simplifying this whole thing all the way to that format is definitely looks kind of difficult. Well, let me just keep that there. Definitely simplifying that all the way to this format seems a bit difficult for this specific problem. So let's actually try the contrapositive approach. You would have okay, if this is odd, that's p of n, and then n is odd, that's q of n. Contrapositive means if not q of n, then not p of n. So yeah. Now, if that means that if n is even, then this is even. So we would write that as n equals 2j, and then let's substitute 2j into this whole thing. That would become 2 minus 6 times 2j minus 2j to the 4. You want to prove that this is even. And now let's simplify it. So that would become, oh, my pencil. Let me switch to a new one. Equals 2 minus 12j minus, this will become 2 to the 4j to the 4. And then from there, we would set that is equal to, we can take out a 2 by now. So 1 minus 6j minus 2 to the 3rd j to the 4. That's taking out a 2 from this part to get here. Now, we have, so 2 times any number will always be even. So we have just proven that not p of n will be even. So if n is even, then this is even. If not q of n, then not p of n, which means that we just proved that if p of n, then q of n by the rule of contrapositive. So we have finished our proof. If this holds true, then also p of n. So if this holds true, then also p of n holds. If this holds true, then this holds true.